Hi, my name is Raimo. I'm an engineer at Rebellion. Mostly we work on hobby and race cars where producing custom solutions are needed. I do a lot of reverse engineering, 3D scanning, 3D printing, product development, and much more. You can check out more from our Instagram page at Rebellion Estonia, and also don't forget to follow. A big news for me. I've become a brand ambassador at Shining 3D, and they sent me some cool things to try out. Einscan HX and Einstar scanner. But in this video, we are going to talk mostly about this HX scanner. But you might see some clips about this Einstar scanner. So we have more material from it. But let me know down in the comments if you'd like to see a separate video of this cool little scanner. Let's see what's in the case, or let's see the case. I love that they put wheels on this case, so you can drive it around. Well, not drive around, but you know what I mean. It has like this, it's like a small suitcase. You can travel with it. So good job, engineers at Shining 3D. Okay, let's see what's inside. I've been using this scanner for a couple of months so far, and I have to say that I really like it. So inside we have a power adapter, a wire to connect your scanner to the laptop. We have an USB stick with the firmware on it. Here we have some markers, so you can get better scans or aligned scans. Here we have different plugs for the adapter, power adapter. So it depends where you're located. You can still use the scanner. And here we have the scanner. I like that it has like this thick foam in it. It's like protects the scanner when you're moving it around, or placing it inside of a car or something in the trunk. And here's the scanner. And it looks nice. And it's light also, so your arm doesn't get tired when you're making longer scans. It has 4 different cameras on the edges. It has 4 LED lights on all 4 cameras. Here is the projector for rapid scan, and here is the laser projector. I like that it has this cool yellow finish on the surface of the lenses. I believe it's some sort of a filter. It has 4 cameras that are surrounded by 4 LED lights each. It's called hybrid LED technology, which improves scanning quality because it has less impact on the ambient light. The scanner can see dark and reflective surfaces much better. On this side, we have cables, power. We have a trigger button. Here you can change the brightness of the scan and also zoom button. I really like that they put a zoom button in here, so I can, scan and change the distance of the scanned surface from my laptop. This is old versus new. This is my old scanner, Pro 2X Plus, and this is the Einscan HX. As you can see, the newer scanner is quite a bit smaller compared with the Einstar. You can see quite a bit smaller scanner. But what about the weight? Let's see. I have my old scale in here. Let's test my old scanner. It's 914 grams versus the new scanner, 722 grams. What about the Einstar with the silicon sock? 600. Oh, let's remove it. Let's see. Not that I would use it without the silicon sock, but almost 500 grams. So in this video, we're going to try out this scanner on my new Volkswagen T-Cross. And before we can scan, we need to decide what sort of scan we want to do. Here is a laser scan and here is a rapid scan. So the laser scan always requires markers because it doesn't use any features while scanning. In other hand, rapid scan can also use markers, but it can also detect surface from its shape. And also when you're using color scan, then by texture. So let's start with placing the markers, because we are going to try out the laser scan function in this video. These are the markers we are going to be using. We have a lot of them. We could scan many cars like this. We could also reuse them by removing them from the surface and putting it back on this plastic sheet. So let's take one and let's start picking. It's better to do it without the glove, so I will remove it. The way you have to place these markers is randomly. You can't have like the same position on this side and also on that side, because it might get confused. In here we have many different textures and also surfaces. Here is reflective, but also like a glass or see-through. This is paint and this is black. So let's see how the scanner handles it. You don't want to place a marker right on the corner of the surface. I will explain that later in the video, and then you can see what happens when I place it right on the corner. So now we have the markers on. Let's continue with the software. In here we select laser scanning. We create new project group, new folder. The name new folder 3 is fine with me. And here we can check, or we can choose or pick what is the resolution of the scan. We're going to go with the medium scan, which is 0.5 millimeter. So now it's ready. Let's pick up the scanner and let's try it out. So here you can see we scanned the front part of the car and something's missing. We are missing the light and also the texture, on the black surfaces is not really good or not picked up by scanner. So what we can do about it is test different settings. We have reflective and black. Let's try out the black first. When I'm using black setting, the software is changing some of the parameters so it can pick up this black surface much better. Also, as you can see, when we get to the corner of the bumper, the scanner is losing its tracking. So what we can do about it is first pause the scanner and then placing some more markers on the bumper. Because sometimes it's difficult to scan right on the corners because it might lose tracking. So what I would like to do on this corner is like putting some markers right on the inside. And now the scanner is not losing tracking. So when we are done with the black surfaces, you could see that it's much more smoother, and yeah, you can see it better. So let's select the reflective setting. Now we use the reflective setting and the surface is much better, but as you can see, it missed something. Glass is not a reflective material, but chrome is. Here when you look like these parts of the scan, on the car we have some reflective materials. You can see that it picked that up really nice. But what can we do about this light? For now, I'm going to remove this surface again. We have to make this surface visible to the scanner somehow. Reflective setting is perfect for example, chrome parts, wheels, basically all that is like a mirrored surface. On glasses or other see-through parts, we would need to use a different approach. One possibility is to use a painter's tape. You can cover the lens with the tape, so the scanner pick up the surface from the tape. Or the second option is using scanning dust. Let's try out how the new method works. As you can see, this method worked out really well. The entire lens, actually on both lenses, were picked up really good. We have some noise, scanning noise, like on top of here, and we also might go for another round for this edge, but we got the surface perfectly. So now what we need to do is generate point clouds. So now that we have this scanner tested and we know what approach we need to use when scanning the rest of the car, let's start placing more markers to scan the entire car. We made total of 3 scans to get all the surfaces I need. The main scan was the biggest, and 2 other scans were taken from the front part of the roof where I could not reach to the other side with one go. If you're scanning a large object or a car like this and you want to get the best overlap when taking multiple scans, I would suggest making a cut as close to the nearest edge as possible. Then aligning the scans with the help of markers and you are done. I want to make sure scan data and alignments are correct with previous scan to the main body. My goal is to end each scan or each stop at about 90 degrees of scanning angle in relation to the body. This way I can be sure that the overlap of previous scans are minimal. Now we can go ahead and clean up the scan from the noise. You can see me doing it the hard way. I'm rotating the scan and selecting areas that I want to delete, holding Shift key and left button to go around the areas like floor and tires and deleting them. The easier way is actually marking part of the scan I need, selecting connected domain. The software automatically marks all the data I need in red. After that, I need to go around the object and see if I missed something or some areas that I might need later. For example, this small area inside the grill. And after that, clicking invert. Now we marked all the areas that I don't need, like this tire and scanning noise. And then we hit delete and we are done. A clean scan. When everything is cleaned and aligned, we are ready to make mesh data. It might take some time. It depends how powerful your PC or laptop is. I would recommend getting as much memory as possible. At first I thought that 16 gigs is enough. Then I realized I need 32. And soon after that, 64. So please don't make the mistake that I made. When you're buying memory, go with the maximum your processor can handle. Remember when we talked about placing markers right on the edge is a bad idea? Here is an example why I should not do that. As you can see, there are holes on the model where the markers used to be. When you start to generate the mesh, the software automatically cuts out markers, and when it's close to the edge, it doesn't have enough surface to fill in the hole. When meshing is done, I would like to check the model again and see if there are any holes that needs to be filled. For example, there is some holes on the right door. I select the manual filling. Filling type is curvature because I want the holes to follow the curvature of the door. Maybe some areas on the bumper too. But I don't mind when some areas are missing or have holes. I don't actually need those areas for my work. Just trying out the software and the HX for my amusement. Something else I like to do is to remove small flotating parts around the scan. We have an option for that too in the software. Click confirm if all is good. Now we move on to the measurements where we try to align the scan. I select create feature, then trying to find some flat planes from the surface. I think I will use the number plate for this one. I will pick 3 points, click create, then choosing point to point on the right side of the car, and finally I select a point on the bumper. Now we move on to the movement, selecting our plane, line and point from the menu, testing some different constraints, later adding some offset to get closer alignment, and later the model could be aligned to the scan data. I only need close enough alignment for this scan for now. But if your model has more flat surfaces with 90 degrees offset, you should get perfect alignment using this method. We are done. Now, I only needed to scan this car just for some design ideas for the roof rack and the additional high beam or LED light at the front. I might do another scan of the roof if I decide to fabricate a ski box or roof rack brackets, and the same goes for the front bumper. And The scanning is done. I have all the surfaces I need to continue my work. It took about 3 hours to complete the scan, but I didn't need the windows, the roof, and the wheels. So if you plan to scan everything, it's going to take longer. We cleaned the scanning noise. We made proper alignment of the scan and made both high and low resolution STL files for work. More videos about the Einscan HX is coming soon, where I plan to use the scanner for reverse engineering to create some cool parts or some cool custom parts. So subscribe for that. And I would also like to try out the Einscan scanner for reverse engineering to see how it compares with the HX. So yeah, thank you for watching. Subscribe to Shining 3D and yeah, bye.